Okay, this podcast is on water. Water is so important for biology to understand the properties and what those properties can do to the water's function. So, water is essential for life, and it's a major part of an organism's composition. So, we're going to learn about the properties. All right, review from our last podcast. Water's polar, so it does not share those electrons equally when it forms the covalent bond. So water forms a polar covalent bond because oxygen is more electronegative and it's pulling the electrons from hydrogen, and so the end of oxygen becomes partially negative and the hydrogens both become partially positive. So as you can see in the diagram, that if the hydrogens are partially positive and then the oxygens are partially negative, that is going to attract. And so one water molecule will bond with another water molecule, and those red little dots, those are bonds called hydrogen bonds. So there are 3 states of water. You have gas, liquid, and solid. In a gas, which is pictured at the top, the gas water molecules are interacting very little. So there's very little hydrogen bonding occurring. When you get to the liquid, you can see that they are hydrogen bonding, they're sticking together, but they can slip past each other because of the fluidity of it being liquid. As the water freezes on the bottom, you can see it forms this crystalline lattice, they call it. There's hydrogen bonding, and those hydrogen bonds are pretty intact, and they're going to last longer because of the property of it being solid. It says fewer water molecules per unit volume in ice compared to liquid water. And so because of that, ice is going to float. It resists heating as the white ice on lakes. Very cold water sinks at around -4 degrees when it's most dense. All right, so a couple properties of water. The higher the temperature, the greater the movement that those water molecules are moving around. One of the properties is high specific heat. Water has a high specific heat. It takes 1 calorie per gram of water to raise the temperature 1 degree Celsius. This is quite high, and that's because water molecules are constrained by hydrogen bonding. Water also has a high heat of vaporization. It requires 540 calories to change 1 gram of liquid water to 1 gram of water vapor, and that's because you have to break those hydrogen bonds. All right, so due to these hydrogen bonds, water is sticky because of those partial positive and those partial negative charges. Water can stick to itself and form water droplets. We'll see that in a minute. That's called cohesiveness, or it can stick to other things like glass, as you can see in the picture, and that's what causes that meniscus, that curvature toward the glass. Water is attracted to itself so strongly. It has a high surface tension, and so again I showed you the meniscus on the last slide, but it also can form droplets on the surface of water, and so that allows really small insects to be able to walk or skate on the surface of the water in a pond. So one reason why water is so important in living things is because water is involved in making molecules and breaking these molecules. When we want to break a large molecule, we need to add water, and that process is called hydrolysis. Lysis means break, and hydro is referring to the water. So hydrolysis is breaking by adding water. The opposite of that is when we want to make bigger molecules. So we have smaller molecules that are going to make larger molecules. That is called condensation, or in AP Bio we call it dehydration synthesis. Synthesis means making or building, and dehydration means we're going to remove a water. So we add water to break, and we remove water to build. All right, another property of water is that water is a super good solvent. It is the universal solvent, actually. And so you can see in the picture that if salt is added to water, the salt, the Na, remember, has a positive charge because of the ionic, and the chlorine has a negative charge because of the ionic bond. So that chlorine, which has a negative, is attracted to the positive hydrogens, and the sodium, which has a positive charge, is attracted to the negative oxygen. And so sodium chloride breaks apart in water, and that happens to a lot of polar molecules and ionic molecules. They will dissolve in water easily.